Hi, I'm Yuriy. I'm doing software engineering and development for the last 15 years. My main tech stack is JavaScript, but on this channel I'm talking about general software engineering, about game development and about Web3. I have just released my latest project, which is a game called Fightback. It's a stylish arcade. I will share a link in the description below. Please install, play, share your comments. I would love to know your feelings and your feedback on the game. Before diving into the next big project, which eventually gonna be a crypto market intelligence tool run by AI, I will share the link into the description below. It's currently a Discord channel. Please join, and there is a channel called AI News Aggregation. Please see aggregation. It gives market news aggregation, and it gives you hints on your possible trade setups. But nevertheless, let's get back to the topic. Before those two projects, I want to make a couple of videos regarding interesting case studies which I have lately faced. One about the async await in C#, another one gonna be in next video. So today we are talking about async await in C#, and especially in the context of the error of application being not responsive, so-called ANR error. The application not responding issue happens when some operation is blocking user interface, and basically user cannot do anything with your application or game or whatever it can be. It's not only that much bad for the user experience, it's bad for your application or game promotion, because stores are tracking such issues, and if you get such issue, you're gonna be lowered in rankings, which can jeopardize all your development. So now let's see how it may happen in your application or game. Let's say we are having very simple scene. On this scene we have a couple buttons which are test button, just prints the test output. We have clear button, so basically those two buttons are UI which is about to be blocked. And we have run sync button. I'm clicking run sync button, and now you can see that UI is completely stuck. Test UI button doesn't work, and after a while it responding again. Now we can try to click run sync once again. Nothing working, nothing clicking, and after a while we have our control back. Now what just happened? In your game or your application, besides the any game logic or application logic, you might find yourself making three kinds of activities. First one is fetching some data from the remote server. Would it be data, or would it be some kind of images, graphs, and so on and so forth. Secondly, it can be file operations, file read, file write, which takes way too much time and going on in the main thread. And third thing, it can be some kind of API calls which are not handled in asynchronous mode as well. Now let's take a look closely what actually happened in our example. What run sync button does, it's actually goes and loads the certain amount of websites one by one in for each loop in sequence. Inside the loop, it calls a download page, and which actually downloads the website page, and after the page is downloaded, it prints out the result. It prints out the URL of the page, and it downloads the page size. And in the most naive way, it tries to update the scroll bar position. So what actually is async and await? Async, that's how we are marking method that is going to await tasks. Funny, right? Now it brings us to the question, what is a task? And task is the abstraction around threading, and generally everything what we wraps into the task is running async. So task wraps any kind of operation and make it asynchronous, and you will have to use async await if you want to feel any kind of comfort to work with tasks. You can, if you have any kind of experience with JavaScript, you can think of task as a promises. Basically, task is a prototype for the JavaScript promises. So now let's take a look how we can solve our initial problem with async, await, and tasks. Now let's add another button, which is going to be run async button. I have prepared this button before, and there is handler for this button. Call it on run async click. Let's go to the code. Here is our new handler on run async click. All it does currently, it's only puts run async click it in the console. Let's try out if it works. See, clear button is clicked. Now let's click run async. Yep, it works. I have run async clicked in the console. So what we can do, we can wrap the on async on run sync click in the task. Let's do it straight away. So we do task dot run, and inside task.run we are calling for on run async click. Cool, now it looks solid. Let's try it out. So let's make sure test UI button working, clear button working, everything is working. Clicking run async, it didn't work. I have nothing on my UI, but I have some output in my console. What actually happened is that inside our render download that result, we got an exception. And this exception saying that we have tried to do something with UI element outside of main thread. It's a specific error for Unity. So Unity is trying to be thread safe, so it prevents you from interaction with UI elements out from the main thread. So to do that, we have to call for a render download result from the main thread. And how to do it with the async await operations with Unity? So we have Unity specific issue and we have Unity specific solution. As I said, we have to call for render download result within the main thread. So we don't have any more option to call the on run download sync in scope of task. But Unity, we can tell Unity that we are operating in the async function. So what we can do, we can tell Unity that this click handler is asynchronous, and then we can run loop, and then we can download page as a task. So we do task run download page. It returns the tuple with URL of the website and the page size, and then we are printing out the result. Let's try it out. Okay, we are loading our sites one by one, and all our UI handlers are pretty much working, nothing is stuck. Now, when our on run async click function is absolutely asynchronous, it's a kind of silly decision to keep running all the things in synchronous way one by one. So what we can try to achieve, we can make our run async function working faster by running tasks in parallel. The first silly thing to do and first silly thing we have is render downloaded result, because currently it's relying only on the URL inside the result, and depending on the URL it generally expects it gets the URL from the list, and it kind of checks index and then kind of checks how much were loaded. It's no go for a parallel download, so let's change the render download result function. So now it will be taking the result of the current iteration, and it's gonna take another argument of how many items loaded. So it's gonna be loaded, that, and instead of strange calculation, we will be just using this loaded. Now we have an error, because render download, it expects to have a result. So we will produce another silly counter, and let's introduce it into our sync load. Yep, on sync load works as expected. For the on-run async click handler, we will have to invent something better than just a counter. We have to kind of track progress of the results, and it won't gonna be linear, it's gonna be parallel. So what we can do, we actually can use the progress. Yeah, it's ChatGPT generated. We gonna instead of ints gonna get our tuples, which are results. And we're going to store our results. It's going to be list of tuple results, and each time we are progressing with the website download, on each progress we will just add another one result, and on the result add we're going to render downloaded count. Everything seems to be simple, but it's not really that much simple, because to call the progress we need to kind of call it report, and to be able to report progress on the report, we will have to pass the progress as an argument to another function. So let's create another private method. It's gonna be called, okay, let's call it download all websites async. So what we have progress as an argument. We don't need this counter. So once we are downloading a website, we are kind of reporting the progress. In our case, we have still the very same loop of the synchronous execution. So what we can do, we can create another list of tasks, in our case, task, and it's gonna be download task, and inside the loop, instead of awaiting the task, we are going to just be adding the task there. So what do we have here? We have list of tasks. It's going to be download tasks. On each task we're going to be downloading. Yep, it's missing the result. We're going to be passing in a bit different space. We going to pass result right here. So it's going to be tuple result download, and now we are passing report and we are returning result. Now everyone is happy. We don't need it anymore. We're gonna await download all websites async. And after all, we will add the output text which saying all websites are loaded. Okay, so we have results, we have progress handler on each site download. We are adding progress handler to result, and we are rendering the result in a progress bar, and tasks are executed in parallel. Let's try it out. So progress bar is working perfectly fine, but we have a report message of all websites are loaded printed way much before the actual sites were loaded. Let's try it out again. So yep. What's happened? Happened that we have the tasks are kind of running, but no one awaits them, and for that we have await Task.WhenAll, and now when all the tasks are gonna be executed, we will proceed WhenAll, and this function gonna be awaited. So the message all websites are loaded gonna be printed only when all websites were loaded. Yep, working as expected. Right, now we are capable to use tasks. We can run tasks sequentially, we can run tasks in parallel. Now let's try to use tasks and async await when we are reading and writing on disk. For the reading and writing demo, we will introduce additional button on our scene. It's gonna be save data to drive button. I have already prepared it before. So it's a button and a simple click handler, which currently is on save data on drive click. Currently, everything what it does is just print into the console save data clicked. For the data, I have pretty much simple user data mock. It's called player progress data transfer object. It holds player unique ID, it holds level, and it holds the record division. I will be using the record revision counter just to prove that the read and write operations are working. I have pretty much simple implementation of the save data manager, and what it does only two operations. It's save data, so it takes a player progress object, converts it to the JSON string and writes to the file. We will get to it later on. And the get progress handler does the very same thing but opposite. So it reads the file, converts the string to the object, and then returns the player progress data transfer object back to us. Just for the demo, we will do the very simple loop. We will increase the player progress record revision by 1. Then we will save player progress, and then we will get player progress and say that progress equals save data manager get progress. And to prove that the counter is increasing, we will just print the latest stored progress revision. Let's try it out. Yep, it does work. It clearly does work, but currently we don't use any kind of async await or any kind of asynchronous programming. Now let's dive to save data manager and let's see what we can do right there. we heavily relying on the two methods, which are read to end and write. What we actually can change, we can in a stream writer, instead of write, we can try to use write async, and instead of read to end, we can use read to end async. Okay, now it's async, and in case of reader, we immediately have to await it. And now we have to change the signature of the method. Now it's public async task player progress dot transfer object, and the good practice is to call your methods with async ending in case if they are async. So now it's going to be get progress async, and we will do the very same stuff with the save progress async. So now it's going to be async task, and they're going to be write async gonna be awaited. Thank you, Copilot. Going back to our demo UI, so save progress. Now it's gonna it's called save progress async. It has to be awaited. Handler gonna be async as well, and stored progress gonna be getting from get progress async, and we have to await it. Now let's have a look on how it works. You have to keep it void. Yeah, still works perfectly fine. Nice. Now we are comfortable with async await, with tasks. We can run requests, we can write and read. Now let's try to combine write, read operations with calls to the third-party API, such as Firebase. In our case, it's going to be just mocked interface, which gonna expose the similar interface you can expect from any kind of third-party API provider. Now, the last exercise is going to be combination of the local API, such as file write, file read, and the remote API. So I'm adding another one button, which is going to be save data to API button. I already have the handler for this button, and now we are going to add some code here. So what we're going to do, we will save our player progress data transfer object as in a previous example locally on disk, and in parallel we will call the remote API. In current case it's mock, it's asynchronous task, which just sleeps for 2 seconds and returns the random user identifier, not a user identifier, but new record identifier from the remote API. So let's do it. As we already know and can, we need some kind of list for handling and storing the tasks which we are going to run in parallel. So let's create a list for tasks which we are going to run in parallel tasks. In parallel, we have a parallel task list. Now what we can do, we can add to the parallel task list call to the remote API. Or no, let's just go easier and just copy paste the code snippet from the previous example. We will just add a save player progress. Currently we have now remote API, so let's add another task which adding the remote API call. Now we have 2 tasks in our list, and now let's await task execution. And at the end, let's put the read record to see that we are actually reading the data which was written before. What we are missing now is the ID, the remote ID of the record. And currently we are not getting it anywhere. So what we can do, we can into adding task. When we are adding task, instead of adding the call for save player progress async, we can pass another task. We can do dot run and pass there a function which actually executes the call to the remote API. Awaited, and awaited call gives us, yeah, it should be async, and awaited call will give us string which is remote ID. Now string remote ID is in the local scope of the task action, and there is no way to get this string value. So let's put the definition of the string on top. By default it's going to be string empty, and inside the task we will just write to this string. So this solution is quite terrible, and if you're kind of keen enough, please share in the comments why this solution is considered to be terrible. But anyways, currently with such terrible solution we have a bunch of parallel tasks saving to the disk. We have remote API call. From the remote API call we are getting remote ID. When two parallel tasks were executed, we are executing another task which is synchronous, and then we are sending all the data to our output. Let's try it out. Yes, it works. So on each call we are getting new revision, and we are getting new unique ID from the API. Now, the general rule of thumb: if you have any kind of operation which takes more than a couple milliseconds, wrap it with the task. Wrap with the task, you use await. In this case, you will not be blocking any kind of user interface, and you will not get the application not responding error. Now, if you want to have any kind of more videos regarding async await, regarding Unity, regarding C#, just let me know in comments. Thank you very much for watching, and see you in the next video. Bye!